Let's look now at the teacher's questioning.
Let's look at these. Let's take a look. Number one, the first one. The first one, we had a piece of paper like this. Is that correct? We had a piece of paper. And where was I blowing? Was I blowing on the top or the bottom, Rachel? I'm going to ask one person, okay? Thank you guys, that was right. I was asking which direction do we blow? Do we blow on top of the paper or under the paper? On top. And what did we see happen there, Heather?
When you blow on top, made the paper go up.
Made it go up. So we had the paper actually moved up, didn't it? Okay, it rose up. That was number one. Number two, we had two pieces of paper like this. And what did we do to those sheets, Shantae? What did we do to those two pieces of paper? Blew into the top, didn't we? We blew down into there. And what happened there, Ricky? What happened to those papers when we blew into them? They came together, didn't they? Good. So we saw this paper rise up. These two papers come together. And then this final one, number three, what did we do there, Mr. Lynch? What did we do to that one? We blew into the funnel, and what did we see happen? Abe, what did we see happen? The ball didn't come out, did it? It stayed right there, okay? The ball stayed right there, didn't go anywhere. Just kind of stayed right there. And didn't it kind of move around and shake around a little bit? But it stayed right there, okay? Let's think about some forces that might be acting on these. Let's think about the paper now. What are some forces that are acting on the paper? Colin? Wind. Okay, we have the wind here. Now, what's another force? Gravity. Which direction is gravity pulling this? Down. So we have a force going down. We have a force going down. Is there a force pushing up, William? How do you know that there's a force pushing it up? Exactly. You know there's a force pushing it up because it moved up. Things don't move without a force. Okay? So William said there's actually a force. Actually, let's draw this here. We've got gravity pulling down, and we've got a force pushing up. Let's label this A and this B. Now let's move over here. Let's move over here. Okay? When we saw this happening, think about forces again. Think about forces. Tally. Can you think of a force that was happening to this? Wind. Okay, wind was a force. That's a force. Which direction did this move? Did they move together or did they come apart? Together. Okay, so where, if they were pushed together this way, where was there a force? Pushing on the inside. That's exactly right. Because if they move that way, you've got to have a force that way, don't they? Okay? And let's say there was also a force here. Let's label this A and label that B. Now let's go here. Let's go here. Mr. O'Neill, can you see with the skeleton in the way? Let me roll him out of the way. Let's take a look at that. Take a look at that drawing there. Okay? What's a force acting on that ball? The wind. You've got a wind, and which direction is that force? Is it this way or this way?
That way.
To the right or to the left?
To the right.
To the right. So you've got a force acting on it this way. Okay, let's label that A. Okay? There's another force from the air, and we'll label that B. Now, let's look at some trends as to why. Everybody pay attention. Number one, which one did we say was greater, A or B? B. So let's get rid, well, we'll just keep this one on here. So we said that B was the greatest force. Which one in number two, A or B?
A.
A, good. And what about number three, A or B?
B.
B. Okay? Now, I want everybody to look closely. Look closely. where do you see, or do you see a relationship between where you blew and which one was stronger? Heather.
It seems like every time you blew on that certain spot, you thought it would go the opposite direction.
Okay. But what actually happened?
It went in the opposite direction of where you
Okay.
thought it would.
Okay, so if it goes in the opposite direction, what does that mean about the force on that direction?
It's greater.
It's greater. So every place you blew, where was the force greater?
On the opposite.
On the opposite side. So this guy named Bernoulli, Bernoulli's law, he thought this up, or he discovered this. He said that every time you increase the speed of the wind, the force goes down. So when I speed up the wind on top of the paper, the force here goes down, this force takes over. Same thing between two sheets. When I blow in here, the force pushing them apart goes down, then the outside force takes over. Okay?
While the teacher in the episode we've seen was working with middle school students, essential teaching skills are important for teachers at all levels. Expert teachers combine these skills to create positive learning environments and provide effective instructional scaffolding for their students.